In this video, we are going to discuss about second harmonic distortion. For a nonlinear region of operation, which is described by the parabolic equation, the output waveform differ from the input waveform. Hence, this distortion is called as nonlinear or amplitude distortion. Suppose if the DC point, okay, this is your Imax and this is your Imin. If the DC point changes, if it is changes means this becomes 2 and this becomes 4, right? Suppose if it is 0, if the IQ is 0 means this is also 4 and this is minus 4. Suppose if this IQ value increases, this becomes 3 and this becomes 5, minus 5. This is due to non-linearity. So because of non-linearity, the output waveform which consists of fundamental and higher harmonics. So this harmonic distortion is caused due to the non-linearity of the characteristics curve of the active devices. So this second harmonic distortion is determined from the dynamic transfer curve using the 3-point method for small signal. One is omega is equal to 0, omega t is equal to 0, and omega t is equal to pi by 2, and omega t is equal to pi. Using these 3 points, we will find the second harmonic distortion. So we know that the alternating current IC is equal to G1 IB plus G2 IB square. We know that IC is equal to beta IB. So this is for DC value, and for AC I am representing IC is equal to G1 IB. So this is this IC represent alternating current, and IB represent the input excitation. So where G1 and G2 is our constant. So I am going to substitute IB is equal to IBM cos omega t. So the waveform shown in this graph. So the maximum value is IBM. This is your Imax and this is your Imin. Since it is a cos value, I am starting from here. Okay. So I am going to substitute the second equation in the first equation. I will get IC is equal to G1 IBM cos omega t plus G2 IBM square cos 2 omega t. I can write cos 2 omega t is equal to 1 plus cos 2 omega t divided by 2. So I am going to substitute this equation in this equation. So if I substitute, I will get IC is equal to IBM cos omega t G2 IBM square divided by 2 plus G2 IBM square cos 2 omega t divided by 2. So you can see the IC is equal to B0 plus B1 cos omega t plus B2 cos 2 omega t. This is a total current. Okay. So I can write this B1 is equal to G1 IBM. B1 is equal to G1 IBM, and B2 is equal to G2 IBM square divided by 2, and this one is nothing but B0. Okay. So this is your B0 is nothing but your DC component due to the rectification of the signal, and B1 is the amplitude of the desired signal at fundamental frequency omega, and B2 is the amplitude of the second harmonic frequency 2 omega, and IC, this IQ represent the DC component of the current. Okay, so first I am going to substitute the first point, omega is equal to 0. If I substitute in this third equation, I will get this cos 0 is 1. Cos 0 is 1, so I will get iq plus b0 plus b1 plus b2. So this is your fourth equation. So omega equal to 0, so at omega equal to 0, at omega is equal to 0, I will get the maximum value, that is I max. Okay, so I am writing I max is equal to iq plus b0 plus b1 plus b2. Next I am going to substitute omega equal to p. So at omega equal to p, I am getting the minimum value. So if I substitute omega equal to pi, cos pi is minus 1 and cos 2 pi is 0. So cos 2 pi, cos 0 is 1. So I will get I minimum is equal to iq plus b0 minus b1 plus b2. So this is your fifth equation, this is your fourth equation. So 2 point we have already discussed, and next one is third point, that is omega equal to pi by 2. So if I substitute omega equal to pi by 2, so you can change this one into omega t. Okay, so omega t is equal to pi by 2, I will get this pi, this one is cos pi, and this is cos 90 is 0. Okay, so I will get iq. So this is, so you can see, so at this point at pi by 2, the value is iq. So iq is equal to iq plus b0 minus b2. So iq get cancelled out, so we'll get b0 is equal to b2. Okay, so from the fourth equation I can write instead of b0, I can substitute b2. So I will get I max is equal to iq plus 2b2 plus b1. So similar way I can replace this fifth equation. I minimum is equal to iq plus 2b2 minus b1. Okay, so on solving these two equations, so if I subtract I max minus I min, I will get so these two terms get cancelled out, I will get 2b1. So what is b1 now? b1 is equal to I max minus I min divided by 2. So what is I max? This is your I max and this is your I min, and this is your IM. So that is nothing but IPP. The difference between I max and I min is IPP. So IPP divided by 2. So what is IPP divided by 2 is IM. So you substitute this seventh equation in the fourth equation. So where is fourth equation? So you take b1 value and you substitute in this fourth equation. So I will get I max is equal to iq plus 2b2 iq plus 2b2 plus b1. Instead of b1 I am substituting I max minus I min divided by 2. I max minus I min divided by 2. So if I solve, I will get I max divided by 2 plus I min divided by 2 minus iq is equal to 2b2. So I will get b2 is equal to I max plus I min divided by 4 minus iq divided by 2. So the sorry, individual harmonic contribution to the harmonic distortion are given by dn is equal to bn divided by b1 into 100 magnitude. Okay, so since it is d2 for second harmonic distortion, d2 is equal to b2 divided by b1 into 100. This was second harmonic distortion. So if the distortion is present, the output power at the fundamental frequency B1 is given by, P1 is given by P1 is equal to Vm square divided by 2 RL, because Vrms square divided by RL. Instead of Vrms, I am substituting Vm by root 2. So instead of Im, I am going to substitute Im into RL. So I will get Im square RL divided by 2. So what is Im? Im is nothing but B1. So P1 is equal to B1 square RL divided by 2. So if I want to get the total power output with distortion, P is equal to P1 plus P2 plus P3, and it will goes on. So if I take P1 common, I will get 1 plus P2 divided by P1 plus P3 divided by P1, and it will goes on, right? So I can write this P1 as B1 square RL divided by 2, and what is P2? P2 is B2 square RL by 2, and P3 is B3 square B3 cube RL divided by 2. So I am taking RL 2 B1 square common. I will get 1 plus B2 square divided by B1 square plus B3 square plus B1, plus it will goes on. So what is B2 square divided by B1? So from this I can write B2 by B1 is equal to D2. So you substitute this one. Sorry, this is D2. So this is D2, sorry. This is D2. So I can write what is D square? D square is equal to D2 square plus D3 square plus D4 square plus goes on. This is not D1. Okay. So for I can write this D, that is total harmonic distortion or distortion factor, is D is equal to root of D2 square plus D3 square plus D4 square, and goes on. Okay. So there is a mistake. So now for the high quality audio amplifiers, the total harmonic distortion is 0.7 at desired listening level. Even though the harmonic distortion of the amplifier increases at higher power levels. So that's all about the video. Thank you.